Good afternoon. So, in the previous lecture, we have studied about the method of speed control of any DC machine. These are the three conventional methods to control the speed of any machine. First one is varying the resistance of the armature circuit by varying the flux of the flux and by varying the applied voltage. So we have studied all these things in the previous lecture. In the conventional method, there are power electronics devices are used to control the speed of any machine. These power electronics devices such as IGBT, SCR, MOSFET are used nowadays to control the speed of any motor. These are the types of DC drivers. According to the input supply is single phase DC driver and three phase DC driver. According to the operation, quadrant operation, it's one quadrant operation, two quadrant operation and four quadrant operation. These are on the basis of the operation of the DC machine. Chopper feed for DC machine, first quadrant chopper drive, two quadrant chopper drives and four quadrant chopper drive. These are the topics we have already studied in the previous lecture. To control the speed of any DC machine, first AC source is converted to DC voltage by phase rectifier, by control rectifier, and DC motor is controlled. This is AC voltage converted to DC by using rectifier to different level of DC voltage, then we control the DC motor. In the second method, by using the chopper, one level of DC voltage converted to another level of the DC voltage, then we can control the speed. For that we use so many chopper, step up chopper, step down chopper, and like other so many choppers are available in the literature for that. Single phase control rectified with separately excited DC machine. The block diagram of this motor is given here to control this is the AC supply. Using single phase control rectifier, we get the controlled output voltage, DC or control output DC voltage. Here we get the control output DC voltage here. So by using this control output DC voltage, on the basis of this we can control the speed of the DC machine. How we control the speed how we can control DC voltage? By controlling the firing angle of the converter, we can change the variable DC voltage. We can get variable DC voltage on the basis of the firing angle of the controlled rectifier. These are the equations of the mathematical equation of the EMF produced by the motor. Back EMF is produced by the motor is directly equal to Km into omega m. Km is motor constant, omega m frequency in RPM. Phi the flux in the machine and torque developed in the motor is equal to directly proportional to phi into I. Phi into I. Armature current into flux. The armature voltage can be get as VA with EV plus IA into IA plus EV plus IA into RA. This is armature drop. So VA will be total EV here K omega m plus IA RA. So speed is directly proportional to speed equal to VA voltage minus IA RA. So this voltage can be controlled by the rectifier converter. VA can be controlled by the converter, so we can control the speed of the DC machine. EV is equal to Km phi omega m. So it is phi directly proportional to IF. So EV is equal to back EMF is equal to omega m IF into omega m. So by this you can see the torque can be controlled by controlling the armature current and field current. So we can control any machine. These are the single phase half wave control rectifier for one quadrant operation. These are AC source, this is one thyristor, which is half controlled thyristor, this is freewheeling diode, this is the mathematical modeling, these are the induction motor with armature inductance of armature, resistance inductance of armature. This is the field current IF and field voltage. So we can control the the output voltage BA by varying the thyristor angle of this, firing angle of this thyristor. So we can get different value of the DC voltage VA. We can control the speed of any motor. So single phase half wave control rectifier, assume the armature current is constant. Here the motor is separately excited with DC motor. Motor is operated from single phase half wave control rectifier. Motor field winding is fed through separate DC source. During the positive half cycle, SCR is forward bias, and with respect to firing angle alpha, it can be turned on, and then we get positive voltage fed to the motor. The free wheeling diode is operated when the thyristor is the reverse bias. So the free wheeling current flows through the free wheeling diode. These are the waveform of the output. This is the waveform of the input voltage. This is the firing angle of the thyristor, and we get like this voltage, like this. So we get final average voltage, and we get thyristor current IT1 and like this, and forward wheeling diode current like this. When thyristor is on, the free wheeling diode will be off. When thyristor is off, free wheeling diode will be on. These are the characteristics of these are the output voltage we will get after half wave rectifier. We get output expression of the output voltage of half wave rectifier like this expression. VA equal to Vm upon 2 pi upon cos alpha. Alpha is the firing angle. So output voltage depends on the firing angle of the thyristor. So we can control the output voltage if we can control the speed of any DC machine. So if we control the output voltage, we can control the speed of DC machine. This is, you can see here the graph between the speed and torque. You can see when alpha is increased in direction, alpha increase, you will can see the when alpha is less, speed is less. When alpha is more, speed is alpha and speed are inversely proportional. Alpha is less, then speed will be more. When alpha will be more, speed will be less. You can see from this graph. The firing angle is large firing angle, so obviously output voltage will be less, so less speed. A small firing angle, you can see firing angle is less, you can see speed is more at that time. These are the graph between the speed and torque with respect to firing angle.